Good morning. We will start session 6 of chapter squares and square, and this is the last session of this chapter. So quickly we'll recapitulate. We have done we have found the square root of a given number as well as decimal number by a division method in our previous session. So we are perfect with that because there were many homeworks were also given. So in today's class we will start. Find the least number to be added or to be subtracted. That means we have one main where we find the least number to be subtracted. Remember, in prime factorization method we had least number to be multiplied or divided, right? In long division method we have added and subtracted. So you should know, if in case the question is asked, they will not ask you it should be done by division method. In case the question is asked, find the least number to be multiplied to make it a perfect square. Then that is a prime factorization method. Find the least number to be divided to make it a perfect square. It is prime factorization method. Find the least number to be added to make it a perfect square. Division method. Find the least number to be subtracted to make it a perfect square. Division method. So let's start. Find the least number which must be subtracted from each of the following numbers so as to get a perfect square, and also find the square root of the perfect square so obtained. I will be only choosing two sums here. Fourth main, first one, 402. So let's start quickly. Again, we know that it is not a perfect square, children, that is for sure, because we need to find what number has to be subtracted to this to make it a perfect square. Looking at this, you can tell what should be subtracted here, 2, right? Because 400 is the nearest perfect square. Okay. 402, how are you going to pair it? This is the way and this. 2 2s are 4, right? So remainder is 0. What will you take down here? You will take it as 0, 2. Now do not do anything adding or doing. Even if you do something, can you actually add or subtract? I mean, can you actually divide that further? No, right? Done. Therefore, 2, whatever is the remainder, 2 is the, here we have got 2, but don't get confused. It's always the remainder. So I just put an arrow mark. 2 is the least number to be subtracted to 402 to make it a perfect square. So 402 minus 2 will give you 400. Now find for 400 children, that is what they have asked. So this is how you do. 2 2s are 4. So 0. So when you take 0 and 0, now so 2 plus 2 is 4. 40 into 0, that is 0 into 0 is square root of 400 is equal to 20. This is how you find it. Let me quickly do the next one. Second one. You have to only find the remainder here. 1989. So let's do the division process. 1989. 19 we have. So 4 4s are 16, 5 5s are 25. So we choose 4 4s are 16. Remainder is 3. Bring this down. It is 389. 4 plus 4 is 8. Now you need to divide this further also. It is not a perfect square, children, so you can't try. You have to only do this by trial and error method. So here start off 81 into 1. Have a tables. 82 into 2. 83 into 3, 84 into 4, 85 into 5. Like that, when you find it for one particular thing, what you will assume that, let me check, 83 into 3, 3 3s are 9, 3 8s are 24, 4 4s are 16, 8 4s are 32, 33. So I think you want. 8 5s is 40. Sorry, 5 5s is 25. So 8 5 is 40. 40 and 2 will give you 42. So we cannot do this. So this is the only number. So 389 minus 36, when you subtract this you get 53. 53 further you can't do anything. Done. Therefore 53 is the, write the statement, least number to be subtracted to this to make it a perfect square. Okay. So 1989 minus 53. How much do you get? When you subtract this actually, you get 1936. So let's do this. 1936 by, when we have to do, so it is 4 4s are 16. What is the remainder? Same thing. 336 you get the remainder as, that is what? 4 plus 4 is 8. 84 4s are 336. Right? Square root of 1936 is 44. This is how you do it. Just find the remainder. Now you are perfect with the division method. Find the remainder. Remainder is a final number to be subtracted. Right? So what are the homeworks children here? So the homework sums will be, which mean it is fourth main. So I'll give you third one, fourth one and fifth one for homework. Quickly we'll start the next one. Find the least number which must be added. Added is different. Added cannot be just taken whatever is in the remainder. There is a slight bigger process for added. Now let's see that how to do it. Same steps what I have written has to be followed here. Find the least number which must be added to each of the following numbers so as to get a perfect square. Also find the perfect square of the number obtained. So fifth main, first one is 525. First our usual thing we do it. 525, group the numbers. So 2 2s is 4. 1 25, 2 plus 2 is 4. So when we have 4 here, now what we have to do children? Check. 41 into 1, 42 into 2, 43 into 3, 3 3s are 9, 4 3s are 12. 44 into 4, 4 4s are 16, 4 4s are 16, 17. I think 129 is the best one. So I will write here 43 into 3 will give me how much? 120. Oh, once again. No, we cannot take this. It's 129, right? I completely forgot. So 42 into 2. So 2 2s are 4, 4 2s are 8. So 42 2s are 84. Even if you don't find the remainder, that is fine because we are not, we do not want to find also. Even if you find it, fine, well and good. So 5 minus 41 is the remainder. Keep this as it is. Don't do anything with the remainder here. Next, how to find our least number to be added? So the procedure here goes is the least number to be added is, okay, quotient plus 1 whole square minus dividend. Quotient plus 1 minus quotient plus 1 whole square minus the dividend. What is your quotient? Your quotient is what? 22. Whatever it is, plus 1 to it. Whole square. What is your dividend? 525. Now, it is 23 square minus 525. This is the procedure. So, when we find 23 square, we get the answer as 529 minus 525. Answer is 4. Therefore, the least number to be added to 525 to make it a perfect square is 4. Understood what we did here? Now add 525 plus 4 is 529. Find the square of 529. We know it is 23, but still we have to find. Please do this below. Since I do not have space, I am doing it here. 529, pair this. 2 2s are 4, 1 remainder, 2 9. So 2 plus 2 is 4. 43 3s are 129. 0. Square root of 529 is equal to 23. Is it very clear? This is how you do it. One more sum I'll do, children. I'll take the next one. And fifth main, third one, fourth one, and fifth one I'll give you for homework. Okay. So I'll keep this one as it is. So the procedure will be the same thing. I need not write it again. Only the answer part I will delete it. Okay. So let's see how to start with this. Second one is 1750. 1750. 4 4s are 16. 1 remainder, 150. 4 plus 4 is 8. So again, when we check with this, let's see. It is not a perfect square. So 81 ones are, 82 2s are. So 2 2s are 4. 8 2s are 16. This will be quite big. So I think 81 ones are itself is 81. What we will do it here is. So let's, okay, even if you don't divide it, it's fine. What will we do here now? The least number to be added is quotient plus 1. Fine, you can even leave it as it is because we are mainly concerned with the quotient. Quotient plus 1 whole square minus dividend. What is quotient here? Quotient is 41. Plus 1 whole square minus dividend is 1750. So 42 square minus 1750. 42 square, when you multiply this, you are going to get 1764 minus 1750. Answer is 14. The least number to be added to 1750 to make it a perfect square is 14. 1750 plus 14 is equal to 1764. Find the perfect square. So pair it. 4 4s are 16. 1 remainder, 64. 4 plus 4 is 8. 82 2s are is 164. 0. Square root of 1764 is equal to 42. This is how you do the sum. right? Quickly, I have given the homework part also. We'll move to the next one. So, sixth one, find the length of a side of a square whose area is 441 meters square. Now children, here they have not mentioned which method. It's up to you. You want to do it by long division or you want to do that by prime factorization. Let the side of the square be x meter. Area is equal to side square. So area is 441 is equal to x square. Therefore, x is equal to square root of 441. Sometimes we know the square root by heart. Actually, 441 is 21 square. Now, which one is left to you? You want to do this by prime factorization? You will do. You can do it. You will get marks. In the question, nowhere it is mentioned. You have to do by division or prime factorization. So let me choose. I will choose long division here. It's not in the working, so we'll do it along with this. So 441, 2 2s are 4, 0. So it is 41. So 2 plus 2 is 4. 41 into 1 is 41, 0. So square root of 441 is 21, that is equal to x. Therefore, side of the square is in the conclusion. (21 meter). Right? Let's quickly start with the next one. I'll just rub this figure so that I can do the second one here. In a right angle triangle, seventh one. So please draw a triangle accordingly, whatever is mentioned. In a right angle triangle ABC, which is 90 degree at C, AB is 6 centimeter, AB is 6 centimeter, BC is 8. Find AC. We all know that hypotenuse is the greatest side. Homework children, 7th main, second one you will take it for homework, first one I am doing. So this procedure you have to follow like this. In triangle ABC, angle B is equal to 90 degree. So always it is square of the hypotenuse is equal to sum of the squares of other two sides. That is nothing but Pythagoras theorem. Pythagorean triplet we have done, right? Pythagoras theorem. So AC square is equal to, what is AB square? 6 square plus 8 square. 36 plus 64 is equal to 100. Now AC square is equal to 100. AC is equal to square root of 100. Now root of 100 you need not factorize. We all know. Write the direct answer. That's fine. AC is equal to 10 meter or centimeter. You want to show factorization by this one, you can do it. But since it is 100, a very small number, we can just write it as it is written. Yeah. Quickly, we'll see the next two sums. So the next two sums you need to understand, it is not a direct perfect square, but the sum tells us somewhere either it is the least number to be subtracted or it is the least number to be added. That we should learn to identify. Okay. A gardener has 1,000 plants. He wants to plant these in such a way that number of rows and number of columns remain the same. Of course, that means he wants a perfect square number of plants. Find the minimum, but 1,000 is not a perfect square, right? Find the minimum number of plants he needs more for this, more for his. Minimum number of plants he needs minimum, don't think it is subtracted. Minimum more how much he can add. Least number to be added, children. Start with this sixth one. Given total number of plants in the garden. Total number of plants in garden. 1000. So number of rows is equal to number of columns according to him, right? That is equal to x. So find the minimal number of plants. So number of rows and number of columns by data. X square is equal to 1000. Therefore, x is equal to root of 1000. We can't do prime factorization. Why? Because it is least number to be added. So 2 and 2. 3 3s are 9. So this is 100. 3 plus 3 is 6. So now let's see with what we want here. 61 into 1, 62 into 2, 61 ones are 61 and 62 twos are 124. No. So 61 ones are 61. What we do it here? Okay, so what we have to do now, it is least number to be added. So then find out the next one. What we have to do for the least number to be added? Therefore, minimum number of plants to be added are, it is quotient plus 1 whole square minus dividend. So quotient plus 1 is 31 plus 1 whole square minus 1000, right? So this is 32 square minus 1000. 32 square is 1024 minus 1000, that you will get it as 24. Therefore, minimum number of plants to be added to make equal rows and columns are 24. Yeah, understood now how it is? So quickly we'll go with the next one, what they have asked. Seventh one. No, sorry, which was this sum question, children? This was 8th one, right? Okay. Now this is 9th one. There are 500 children in a school for a PT drill. They have to stand in such a manner that number of rows is equal to number of columns. How many children would be left out in the arrangement? Least number to be subtracted. Again, total number of children. Total number of children is equal to 500. Number of rows is equal to number of columns, that is equal to x. By data, x square is equal to 500, x is equal to root 500. 2 twos are 4. 100. 2. So 4 I will take here. So next what I will do here is 41 into 1, 42 into 2. So 41 into 1 is 41, 42 into 2 is 84, 43 into 3 is 129. So this will go with here. 42 into 2, you will get that as 84. Remainder is 16. Therefore, number of students, what I have asked? Number of how many children left out? Number of children left out. Number of children left out in arrangement are 60. This is very clear. So with this, we complete the chapter squares and square root. There are many worked example sums also where you can practice to be more perfect in this chapter. So the next chapter I am starting with is cubes and cube roots. It will be a continuation. It's a very small chapter since we have understood squares and square root. Now let's see cubes and cube roots. Tomorrow's session we will start, but I want you all to practice perfect cubes till 1 to 10. 1 cube is 1, 2 cube is 8, 3 cube is 27. So please practice perfect cubes till 1 to 10.